Welcome back. Now that we understand what multimodal systems are, let's dive into the fundamental concepts that make them work. How do we actually get computers to understand different types of data together? Let's break it down. Imagine you're building a system that needs to understand text, images, and audio all at once. Each of these types of data is fundamentally different, right? Well, let's visualize how each of the data starts. Text is just a sequence of characters. Images are just a grid of pixels. Audio is just a wave of sounds, and then video combines images with audio over time. Here's what these look like in their raw form. But here's the key. To work with multiple modalities together, we need to transform them all into a common format, usually vectors of numbers. Think of it as translating different languages into a universal language that our computers can understand. Let me show you how this works. When we convert our data into vectors, we're essentially placing them in a mathematical space where similar items are closer together, different items are further apart, and then relationships can be measured and compared. Now, how do we get from raw data to these vectors? This is where feature extraction comes in. Think of it like extracting the important characteristics from each type of data. Let's break down the process. First, you take raw data. Second, you identify the important patterns. Third, you convert these patterns into numbers. And then fourth is combining them into feature vectors. Here's a simplified example of feature extraction. This is where neural networks come in. They're like the universal translators of the AI world. Let me show you how they work. Picture a network with three main parts. We have an input layer, which receives our different types of data. We have a hidden layer, which learns patterns and relationships. We have an output layer, which produces unified understanding. Watch what happens when we feed different types of data through the network. Once we have all of our data in the same format, we need ways to store and retrieve it efficiently. This is where information retrieval comes in. Think of it as like organizing a massive library where books, our data, are organized by topic. Similar items are shelved together on the shelves, and then you can quickly find what you need. Here's how we might implement a basic retrieval system. The beauty of these fundamentals is they work across all types of data. Whether you're processing text, images, audio, or video, the same principles apply. Let's look at a quick real-world example. When you search for a video online, the system processes the title, text, analyzes the thumbnails, images, understands the audio content, and then combines everything to find the best match. Before we move on, let's try a simple exercise. Think about an application that you use and identify what type of data it processes, what features might be important, and how it might be combined across different modalities. Understanding these fundamentals is crucial because they form the building blocks of all the multimodal systems. In our next lesson, we'll dive deeper into each of these concepts and start building real systems.